All right, this is 7.RP.2.a. This is ratios and proportions, standard 2, subpart A, and we are going to be talking about the slope of a line. Now, according to this standard, they want us to start talking about proportional relationships between two quantities. And before we get into talking about proportional relationships, I would like to talk about what a straight line looks like, what it's called, how it appears to be on a coordinate plane, and then how steep a slope is. And if you're thinking about skiing, you're talking about hills and how steep the hill might be. The easier, they used to call them what, bunny hills, and then they have the very, very steep, dangerous hills. So we're talking about slopes of lines today. Very vocab heavy. I have a number of words that I would like you to write down in your journals and define them. I'm going to talk about them in this video, but I really like you to get the wording down in your journals, and then we'll bring those to class. Okay, the first one is called a positive slope. And looking at this purple line, I notice that it's going in a certain direction. I have a line going from the lower left quadrant up to the upper right quadrant. And the way that I teach it, it's going to be very simple right now. I'm not going to talk about, the relationship, of the x and y values, as I will be in the future videos. As the x values are increasing, it appears as though the y values are increasing. What I'm going to talk about instead today is very simple. What direction is the line going, and how do you know that it's positive? And I think of it in terms of reading a textbook, reading a book of your choice. I start from the left and I read to the right. So I'm going to do the same with this purple line. I will be reading from the left of my page to the right of my page, okay? So if I were to do that, and I have the bottom of this arrow of the line, and I read it from the left to the right, it appears as though that we have a little mountain climber, I guess you could call him, and he's climbing the mountain, right? What direction is he going? He is going upward. So that means if we're going up in math, we call that positive direction. Okay, so if I'm reading from the left arrow to the right arrow, we are going in a positive fashion. So this line is a positive slope. Same idea. I'm going to read from left to right, my purple line, and I have my mountain climber, and it appears as though now, what direction is he going if I go from left to right? He is going downward. And when we talk about math terms going downward, we're talking about them being negative. So this is a negative slope line. And then the third one that we're going to talk about is this thing called zero slope. So if I am walking from the left to the right, it appears as though I am not going either upwards or downwards. I'm going straight. And this is actually the kind of ski hill that I enjoy. I like being on flat ground because it's very dangerous for me when I'm on skis. Trust me, you don't want to see that. So this is a zero slope line, no slope. All right, now the standard wants us to talk a little bit about finding slopes. So yes, I see that it's a positive slope. You probably recognize that already. But if I were to find the actual value of the slope, we talk about it in terms of the rise over the run. All right, let me write that down here. So m, the slope, is equal to the rise over the run. Now, what do I mean by that? Well, it means I'm going to find 2 points on my line and calculate it as a fraction. So if I were to take, let's just call this point right here, where my red line crosses 2 grid lines, call it a hit point. You could call it a bullseye, whatever you want to call it. It's where the line hits two grid lines. Now, let's follow it along again here. It doesn't hit two grid lines there, but it does hit my two grid lines at this point. Follow it again, and if we go to the left, it looks like we hit one time and then two more times. All right, so if I'm going to find this as a fraction of the rise over the run, that means take any 2 points on the line and count the units. All right, so I'm going to take this random point right here in the middle, and rise means like a helium balloon. This balloon is going to go, if it's filled with helium, it's going to go upwards. All right, so let's follow this upward, and I need to get to my point. I'll call them point A and point B. How about that? Maybe it'll make it easier. So I go point A and point B. So if I go upwards, that means up 1 is positive 1, and then I need to get to point B, so I'm going to run 1 unit, 2 units. So running to the right means plus 2. So if I were to put it as a fraction of the rise 1 and the run 2, what is my fraction? Well, my slope is equal to positive 1/2. Now let's take a couple of other random points. Maybe I'll call this one down here point K and point L. Why I chose those? I don't know. I just picked them out of the blue. Let me erase all this stuff. All right, so we said if these are points on our line, they should all have the same slope. So let's pick out K to L. If I were to go from K to L, I would have to rise 1, 2, 3 units. So when I go upward, it's 3. And when I run across to get to L, 1, 2, 3, 4, 5, 6 units. That I went to the right, so that's positive 6. If I were to put it into my rise over run, it would be positive 3 over positive 6. And what do you get if you reduce that? Well, we get the same answers we got before, 1/2. So our slope would be 1/2, no matter what 2 points we take on our line. All right, now it says draw the graph of the line that passes through the 2 given points. So the 2 given points, we just learned how to graph these on coordinate planes. So let's just graph these 2 points of 3, 4. So we go from the origin to the right, 1, 2, 3, and then up 1, 2, 3, 4. It's different from finding the slope. You know, when you're finding points on a grid, you always start at the origin and go, to the right or left, and then up or down. So now it's kind of like opposite when we're finding slopes. All right, let's go plot point 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay, now if I had a ruler or a straight edge, I'm going to create this line for you right here. And if I were to connect my 2 points all the way through my grid, I can now find my slope. And the slope would be, again, the rise over the run. Now I'm going to do it backwards. I know that if I went up 1, 2 units and to the right 2 units, I'd have a nice slope. But I'm going to show you that you can also fall and go left. So knowing that I go up 1 and up 2 and run 1 and run 2, I have a 2 over 2 slope, which is reduced to 1. And then I'll do it in a different color. I said I was going to go opposite now. You can also go down 2. So rise is not only up, rise can also be downward. So think about it in terms of a balloon that runs out of helium. As it falls down, 1, 2, you're going -2. and then to the left 2, we would have another negative 2. And if we were to write that as rise over run, we would have negative divided by negative is a positive. So this is also a +1 slope. All right, the last part of this is the main part. We're going to be talking about constants of proportionality. We're going to be talking about rate of change. And if I'm looking at this graph right here, it has a comparison of time versus dollars. Okay, so let's label our axes. Just to recall, the axis that goes horizontally is the x-axis. And the axis that goes vertically is your y-axis. So we have the change in the x values relating to the changes in the y values. All right, now let's put some numbers in there. What might we be talking about? If we have time in hours and dollars, some of you might be getting into the land of babysitting right now. So if I have labeled numbers here, I might say that where the lines connect, we're at 0. And then, you might get paid by the half hour or the hour. So I'm going to skip a line. That'll be a half hour. So this is 1 full hour, 1.5, 2 hours, 2.5, 3 hours, 3.5, 4, 4.5, 5, and you could keep going. And then when it comes to dollars, you might be getting paid, I don't know what the rates are these days, but you could be going maybe by increments of 8. So, let's skip a grid line. That could be 4, 8, 12, $16, 20, $24, 28, $32. And we could just create a bunch of different points out there. So let's pick some points of interest. I would say maybe after 1 hour you get $8. That's a pretty good rate. I'll take that. And then if you kept a constant rate, so if for every 1 hour you work, you make $8, what would you make after working 2 hours? Okay, so another $8 would get you to $16. And at 3 hours of working, if you kept the constant rate, you would be up at what? $24. And then how about after 4 hours, you'd be working or making $32. And you can see this nice straight line that's coming down. And if we were to talk about the slope of this line, we know that the slope of the line is equal to the rise over the run. So we're talking about the x value. So what would we have here? The x value is your run, right? So x would be in the bottom, and your rise is your change in the y-axis. So let's take any points on there and let's divide. So if I were to take the last one that we did, we would say 32 is the rise and the run was 4. And what does that equal? Well, that equals 8. So you're going to make $8 per hour, and that's a nice unit rate. Take another point. So maybe we take this point right here, and it says 24 per, what was that, 3 hours? So you're going to be making, again, $8 per hour. Okay, and if you were talking about a simplified slope, you could call the slope m is equal to 8. And we have a constant of proportionality, which we're going to get to in another video. We have a rate value. We've been talking about rate, $8 per 1 hour. Okay. In your journal, please define the given terms on page 2 of the flip chart. I know there's a lot of them. And I'd like you to write a few sentences on what you learned from this video. And we'll talk about those in class.